Okay, so this last section deals with steps 3 and 4 of, or rule 3 and 4 of simplifying a radical, and that is you cannot have a radical in the denominator of a fraction. Okay, and so most everybody here has done rationalizing denominators, yes? And probably what you've done has been limited to square roots. Okay, so this should not be anything new to you. Again, if it is, I'm still going to present it. Okay, but it should be something that at least looks familiar. And now the wording that I'm going to use to describe this step is probably different than what you guys learned when you rationalize denominators, because the wording that I'm using is going to apply to all radicals. Okay? The wording that you guys probably had was you simplify your radical, and whatever's left in the radical, you're going to multiply your whole fraction by that over itself. Okay, that is the rule for this. But the way I'm going to describe it is, okay, step 1, simplify radical. By doing this step, it allows you to work with the smallest possible bases that you can use. Okay, so you're going to rewrite your number in exponential form. What that means is if you see a perfect power, so a perfect square, perfect cube, or so on, you're going to look to rewrite it in the exponential form with the smallest base possible, because that gives you small numbers to work with. Okay, this will be more appropriate when you're trying to rationalize cube roots, fourth roots, fifth roots, and so on. Okay. So this example here is already simplified. Okay. The next thing you're going to do is you're going to multiply the top and bottom by the same index, same base. And notice this fraction that you're going to multiply by is going to have a value of 1. It's some number over itself. Because it's the identity property of multiplication, you can multiply something by 1 without changing its value. So you're going to multiply this by a fraction whose value is 1. But this fraction is going to be radical with the same index. And the same base as the denominator. Okay, so what is my index going to be for this? You look at my original denominator. The index is 2. So I'm going to leave it as square root, and my base number is also 2. Okay. Now, here's the step that's kind of added. With what you guys have done before rationalizing denominators, this is all you have to do, and then you can just multiply across the top and across the bottom, and it simplifies out. If your index is something other than 2, what you need to do is, in this new base, you might have to take it to a power so that the index and the new power are equal. Okay, so I'm going to come back to this step in the next example. Okay, but this red step here mostly applies to an index that is something other than 2 or other than a square root. Okay, so here when you look at this, take it to a power so the index and the new power are equal. When we multiply across the bottom here, really what we're looking at is what's 2 times 2? It's 2 to what power? Second, is the index and power, are they the same? Are they equal in that step? Yeah, that's what I'm talking about again. With the square roots, it is just what it is. You don't have to think about that step. But for some of the other indices, you do have to think about it. When I multiply across the top here, 1 times root 2, I get root 2. Well, this fits that pattern of the nth root of a to the n. Whenever you have an index and power the same, you can just remove your base. So the denominator becomes just what base? 2. Okay, the square root of 2 squared is just the base 2. And then the top remains the square root of 2. So 1 over root 2 simplifies to the square root of 2 over 2. Questions about that? Because that's the step that you've seen before. And everybody should be familiar with this. Hey, what if you have something where, let's add one layer of complexity. 1 over the square root of 50. Okay, see if you can rationalize this just really quickly. Is there anything we can do to apply this first step? Simplify the radical? Are there any perfect squares you can remove from 50? 25 times 2. The square root of 25 comes out as a what? 5, and the root 2 stays. Okay, so what we can now do is perform the next step, multiply by a value of 1 with the same index, same base. Make sure that the sum of the powers of the base are equal to the index. So 2 to the 1 plus 2 to the 1 gives you 2, the number 2. 2 is identical to the index of 2, so this is all we need to do for our rationalizing step. And then the final step is just to multiply across the top, root 2, multiply across the bottom. We have our 5, and then root 2 times root 2. It's always going to reduce out to just the base of 2. And so to simplify completely, multiply 5 and 2. And so we wind up with root 2 over 10. Okay, questions on that? Again, this should be review for you. Okay, what's going to happen, though, when we start to do cube roots? Okay, so let's take 3 over the cube root of 2. Okay, let's see how these steps apply in this case. Okay, all the steps are going to follow the same pattern. Okay, simplify our radical. Okay, there's no simplifying here. There's no perfect cube factors out of 2. So we're going to multiply by a value of 1. The index is going to be the same. The base is going to be the same. And the sum of the bases in this denominator have to match the index. So what is the index here? The index is 3. How many 2's do we have right now? So we have the 1 to start with. How many more do we need to match the index? We need 2 more. Okay, so when you choose to rationalize, you're going to rationalize by 2 squared because we want the sum of all these powers, this 1 plus these 2, to equal the index 3. So now you can complete the step, multiply across the top, 3 times the cube root of 2 squared, which we can simplify. What is 2 squared? 4. And then across the bottom, again, what you're really looking at is you have the cube root of 2 to the first times 2 squared. When you multiply two numbers with the same base, what do you do with their powers? Add them. 1 plus 2 is cubed. If you follow these steps, this index of 3 and this power of 3, always going to cancel. And so you have your simplified form, 3 times the cube root of 4 all over 2.